coming. Thank you to Maynard, by the way, who helped me organise it. Thank you to Hannah for buying the beer. And thank you to the BCS for actually paying for everything. Awesome.
Hello, everybody. Hello? Can you hear me at the back? Where's going to ignore me? I don't know. It's up to you. Hello, Jimmy. Hello. How are you? Good. Hello. I'm John, second year physicist over there. And I'm here to talk today about one of the projects I'm doing at the moment, which is a project called Robot Ants. It's a look into robotic thinking and problem solving. It's an idea I've had for a while. The idea is you have a group of almost swarm robots which all defer to this one queen bot, kind of like ants do in real life. And the main aim of these robots, these ant robots, will willingly give their life to get this queen bot to wherever she needs to go safely. Okay, so this is the first part. There's a principle of ants. I have actually, this is a prototype. This is one of the ant bots. They're not that small. They could be smaller, but it gets more expensive, unfortunately. And the idea is that these robots all work together to accomplish a simple goal, which is normally getting the queen bot from A to B. The A bot has, the queen bot is the central processing unit for the entire system. It is the one you give the commands to, you tell it where you want it to go, you tell it what its main aim in life for the next 5 minutes is going to be. The other robots are small and they follow them kind of like ducklings follow their mother. They all kind of go in a nice line behind. There's sensors on the front and back of each of them. They're very cheap to produce. They only cost about £50 each to make. So they're not actually that bad priced. And the whole thing is used using basic sensors and relational positioning. The relational positioning is one of the sticking points I've had in this project so far. It works on the principle that the robots are never closer to each other than a certain distance, and they'll turn when they reach a certain point. The problem is not all of the servos are the same. Some are older than others because most of them are second hand. So some of them turn more than others, so we end up with problems where one of them gets lost and then turns around in circles trying to find itself. Which is quite funny to watch, but isn't very good when the queen bot goes, right, come here you, and he goes, oh, where are you, where are you, and just has a fit. The queen bot is considerably bigger than the ant robots, but she carries various modules to specialise them. The project thinking at the moment is that the queen bot will look something like the Mars rovers. So it will be a large flat base on top, and there will be bays underneath, which will have in them almost like robotic, kind of like sonar, laser positioning, well, like a laser eye thing. And if enough of these join together, you'll also build up a 3D picture in the end. And the idea is they give all the information back to the ant queen bot, who then decides, right, we need to do this. One of the simplest applications of this, which I've thought of so far, is to have a set of stairs. Because obviously a robot that's on wheels tends to have trouble going upstairs. But what if we turn those stairs into a ramp? So we have simple ramp modules, which basically turns the front of the ant bot into a ramp, which the queen bot can then drive up. But obviously then you're going to lose 2 of the ant bots, so how do you get them back? The queen bot has a magnetic crane on the top, which can reach over and pick up the ant bot to rescue it, so it doesn't leave any of its own kind behind. We're not into any kind of evil queening here, kind of thing. We quite like everything to be friendly and happy. This isn't anything like Skynet. They aren't all going to take over the world. When, you know, if they decide they don't like us, they aren't going to come for us. But the actual thinking behind it is quite simple. It's based on a system that we see every day in the world, and just kind of blowing it up and making it electronic.
Do you really blow it up?
Depends. There's nothing wrong with having an explosive module, but then you start losing robots. We don't like that. Then it gets expensive. The programming is one of the stickiest phases we're at the moment. We have the Wi-Fi system here. The problem with Wi-Fi systems, obviously, everywhere nowadays has Wi-Fi, which means you get interference, you get problems like that. It is, however, more reliable than radio electronics, which is what we're using at the moment. This is one of the reasons I want the Arduino board. So I'm going to throw that in there right now. I want the Arduino board. Okay? it's basically, as Arduino board, I've had a look at it, and you can do right. You have to attach a few of them together because you need that amount of outputs. But if you were to connect them up to a very simple bit chip and then a few Wi-Fi nodes, you could have all these different little robots running around, powered by 3 Arduino boards. I've worked it out. You can have 3 Arduino boards powering up to 15 ant robots plus the Queen robot. Obviously, that's just a one-way system. Because of the Queenbot is essentially blind, you have the eyes modules, which we were talking about earlier. They are used by the ant robots to go out and get more information, which obviously has to be relayed back. So there has to be a two-way communication going on. And that's about all I've got. So thank you very much for watching, thank you much for listening, and I would like the Arduino board. At all, or I've run out of time. Are there any questions? Go on then.
You said you have 15 of the animals. How many ideally would you want to have for scouting out around?
You wouldn't actually need that many. You would only need, well obviously humans have 2 eyes. If you were to use sonar, a couple of sonar sensors in front of each ant block, or a couple of sonar modules, you only need 2 of those for powering. You only need 2 rounds, for instance. You only need about 10 to accomplish most simple tasks. Anything else? No? Well, thank you very much, and enjoy the pizza and the beer. Don't forget, I will be on.